Hi guys, welcome to another video. The topic for today is fractions and decimals. With this topic, we take our entry into the concept of number system. Okay, it's an important topic, easy topic. You can solve the questions easily if you understand the concepts well. Alright, so without further ado, let's jump into it. Alright, so now when we talk about number system, right? So numbers, your numbers can be broken into two parts or can be categorized into two parts. We have real numbers and complex numbers. Okay, if you take a time to think, what are real numbers? Numbers that can be represented on number line. Okay, all the numbers that you can represent on a number line. What is a number line? This one, middle value is 0. If I go 1 to the right, the value increases by 1. If I go to the left, value decreases by 1 and so on, right? So any number that can be represented on this number line is classified as real number. Complex numbers automatically not on number line, right? If you think about it, these are right imaginary numbers. Right, if you push your brain up, press your brain a bit, iota, right? Something that we have studied way back, right? Iota. Now, good thing about our exam is complex numbers are not in our syllabus. So all we have to do is we have to concentrate only on real numbers. Okay. Now your real numbers are again further classified into rational and irrational numbers. Okay, rational numbers are what? That can be written in P by Q form. Okay, a number divided by another number. Okay, rational numbers are numbers that can be written in P by Q form. Obviously, Q is not 0. Okay, so what are irrational numbers? Simple, cannot be written in this form. Right? We'll look at them little later. Rational numbers are then divided into two types. Right, these are your integers and fractions or decimals. Okay, what are integers? 1, 2, 3, 10, 20, minus 10, minus 100, but they are all part of rational numbers. So if I just extend the definition, here Q is 1. Right, if you think about it, 1, 2, 3, minus 10, 0, 100, the denominator of all of these is 1. Right, so rational integers are simply rational numbers with Q as 1. Fractions and decimals, obviously Q is not 1. 1 by 2, 3 by 2, 4 by 3, right? 0.5, right? These are all fractions and decimals. Decimals rather are then classified into two types. Okay, these are terminating, non-terminating. Right? Non-terminating, right? Terminating are which, as the word suggests, terminate. Terminate means end. So 0.5, 0.25, 0.125, 3.75, okay, 3.78, that end after a certain value. Non-terminating, that do not end, 0.111111, 0.3333, right, like that. So these are then further classified into two types, that's recurring or repeating and non-recurring or non-repeating decimals. Okay, these are then further classified into recurring decimals and non-recurring decimals. Okay, now important point, recurring non-terminating decimals are rational numbers. Okay, so your 0.3333, which is 1 by 3, right, is a rational number because it can be written in P by Q form. We'll learn how to convert those recurring decimals into fractions a little later. All your non-recurring, non-terminating decimals, these are all irrational numbers. Okay, non-recurring, non-terminating decimals, these are all irrational numbers. So numbers such as root 2, okay, numbers such as pi. Okay, now pi might put you off a bit, because we all know that the value of pi is roughly 22 by 7. But remember, it is roughly 22 by 7. The exact value of pi is not 22 by 7. Okay, an approximation is 22 by 7. The exact value of pi is not 22 by 7. That is why pi is irrational. Okay, alright, does that make sense? Let's move to the topic at hand. So today we are focusing only on fractions and decimals. Okay, now when we talk about fractions, what are fractions? So we just said they are p by q form, q not 0 and not 1, right? Such as 3 by 2, right? 23 by 6 and so on, right? These are called your normal fractions. The same values can be written in mixed fraction form. Okay, the same values can be written in a mixed fraction form. So your 3 by 2 can be written as 1 by 2. Okay, how do we get this? Right, you simply divide 3 by 2, right? Sorry, quotient is 1, remainder is 1. The quotient goes here, the remainder goes here. Okay, let's take another example. Say we have 23 by 5. Okay, this will be written as 4 3 by 5. Okay, why? Because again 23 divided by 5, quotient is 4, remainder is 3. So the quotient goes here, remainder goes here. Okay, so fractions can be written in two ways: normal fraction with a numerator and a denominator, or they can be written in mixed fraction form. Okay, how do we write mixed fraction? You just have a quotient, remainder and your divisor. The same thing then are simply converted to decimals. Okay, instead of stopping here, okay, so instead of stopping here, okay, I had this 23 by 5, which was 23 5 4 quotient. If I do not stop here and if I continue with my division, okay, I put a decimal so that I can take a 0 here, 6 30. If I just continue with my division, then what happens? I get a decimal. Okay, so 23 by 5, which is 4 3 by 5, is simply 4.6. Okay, so the same fraction has now been converted to a decimal. So that is why we say fractions or decimals, because they end of the day mean the same thing. Okay, they don't mean two different things. Fractions and decimals are essentially the same things. Okay, so what we are essentially trying to say is that, see, if a by b, okay, is a fraction, this can be written as q r by b. I have converted the fraction into a mixed fraction, which can be written as q point p, a decimal. So this is your normal fraction, which has been written in mixed fraction, which then has been written in decimal. So it's the same number 23 by 5, which can be written in three different ways, right? The same number 23 by 5 can be written in 4 3 by 5, can be written in 4.6, three different ways. Okay, now if you try and think what is the takeaway from this, okay, so our takeaway from this is that, see, a is 23, b is 5, q is 4, the quotient is 4, remainder r is 3, 5 is my divisor, b only, this 4 is again the quotient, this is my decimal. So the point being that the decimal is nothing but remainder divided by divisor. Okay, the decimal point p is nothing but remainder divided by divisor. And whenever you write a fraction in a decimal, the value before the decimal, this is your normal quotient. Okay, the value after the decimal, that decimal comes from remainder divided by the divisor. If you're writing the same fraction in a mixed fraction form, the value outside is your quotient, the value on the numerator is your remainder, denominator is your divisor. The point is, we are just learning how to convert your normal fraction into a mixed fraction into a decimal, how this interchange happens. Okay, you need not worry, we will study this in much more detail when we cover the topic remainders. Okay, there we will study all of this all over again and we'll practice questions based on this. Okay, so moving on, right, let's understand decimals and fractions into much more detail. So see, if you have the same thing, 23 by 5, which is 4, 3 by 5, which is 4.6, right? So when we talk about a decimal is ABC point XYZ. Okay, so before decimal point you have certain values, after decimal point again you have certain values. All right, now these values, this C is your units digit. Okay, everybody knows this, we call it units digit or ones digit. Okay, B, right, B is correct tens digit, hundreds digit, and so on, right? So you have units, tens, hundreds, thousands, and so on. Okay, but interesting thing is, okay, the value after the decimal, this does not start with units. Okay, because this x is basically by 10, right? When you divide the number by 10, that is when you get your first decimal. So this is your 10th digit. Okay, the th comes. Okay, this is your 10th digit. The second value then is 100th digit. Okay, the second value is then 100th digit. Okay, the th is important. Okay, the th is important. So this is your 10th digit, this is your tens digit, 100th digit, hundreds digit. This will become 1000th digit. Okay, so remember, this is the nomenclature. Before decimal you have units, tens, hundreds. After the decimal we have 10th, 100th, 1000th, and so on. Okay, now why do I need to know this? Why do I need? Because this comes right up in our exam, obviously, that is why. And another, we have the concept of rounding off. See, when you do data interpretation or when you do graph based questions, right, in order to solve certain questions quickly, we do try and approximate things, right? So how do we approximate? We have to round off the numbers. Okay, so how does that work? So say for example, I have a number 25.672, units digit, tens digit 25, 10th, 100th, 1000. Okay, now how the concept of round off works is, we are trying to, okay, approximate the number. So what do? We try to look at a number below it and a number above it, and we see which one is closer to it, and we round it off or we approximate it to that. If number is closer to the lower value, we round down. If the number is closer to the greater value, then we round up. Okay, so typically values 0 to 4 are rounded down, values 5 to 9 are rounded up. Okay, what does this mean? That if I want to round this down to say 100th digit, okay, if I want to round this to 100th digit, okay, that means here. So I don't want this value. Okay, so I look at it, this is 67, it could be 670, that's the lower range, 680, that's the higher range. Now 672 is closer to what? 72 is closer to 70, right? If you think about it, see what are the ranges, because this I want. So lower is 70, higher is 80. 72 is closer to what? It's closer to 70, right? So when we round to the hundreds digit, we get the answer as 25.67. Okay, now similarly, if I want to round this to say 10th digit, right, 10th digit, okay, that means I want this, I don't want decimals after that, okay. So then don't look at the nearest number, look at the number as a whole, okay. It's an easier way to understand, okay. Look at this 72, right. Again, if I look at the lower range, that's 600, higher range, that's 700. 672 is closer to what, 700 or 600? It is closer to 700. So when I try to round it off, it will be 25.7, okay. It will become 25.7, okay. Let's take an interesting example, right, to understand this little more. I want you guys to try 25.639, okay. I want you to try round off 25.639 to the 10th digit, okay. Or let's do one thing, okay, really sorry, let's make this question even more interesting, right. Let's do this as 25.649, okay, 25.649, okay. Now there are obviously two answers, 25.6 or 25.7, okay. Which one did you get? No, if you're saying this, that's wrong, okay. Why? Because see, why? Because see, we sometimes have a habit ki, okay, if I want to get here, let me first start from here. You will round off the 9, this 4 you will make it 5. Now the 5 will make the 6 7, right? That's wrong. As I told you, don't go number by number, okay? Look at the number as a whole, alright? Or in other words, if I want to round off till 6, then only focus on this 4. All the numbers after that do not matter, okay. How does this work? So see, as I said, if I want this decimal, look at the range, 649, the range is 600, upper range is 700. Now think, 649 is closer to what? Is it closer to 700 or is it closer to 600? It's closer to 600, right? That is why this, when you round off, right, to the first decimal, the answer becomes 25.6 rather than 25.7. So remember, whenever you are rounding off, don't go digit by digit, okay. Till wherever you want, post that, consider everything as 0, or look all of the digits as 1, okay, as one whole number, all right. I hope this makes sense. Alright, if it does, then let's try and solve one question. So we have k, value of k is given. K star is the decimal obtained by rounding k to the nearest hundredth. Hundredth means the second decimal, right? Let me just write it here. So k is 3.2679. Till here I need to round off, okay. Till here I need to round off. Now again, if you guys know, if you're rounding off here, so k star will be, right? K star will be, the upper limit will be 600, lower limit will be 700. So when I round off, this will become 3.27, okay. Or else, don't focus on this 9, just look at this 7. What will 7 do to 6? It will round it up. So you know this is 3.27, okay. For the sake of the question, I'll just write 0 0, alright. So I have my k star, I have k. What is it that they want? K star minus k, right? So k star minus k is 3.27 minus 3.2679. That's 0021, right? That is 0.0021, okay. Alright guys, let's look at another example. So we have a number, right? Hundreds digit, n is the hundreds digit. It's rounded to the nearest tenth. Okay, so the number is 5.3n8. This is the hundreds digit. Now what do we want? We want to round it off to nearest tenth. Okay, which of the following could be the tenth digit? Alright, clearly I don't know n, right? But what I do know is, if this is 3, so this can be rounded off as 5.3002 or 5.400. Okay, if it is rounded down, it will be 5.3. If it is rounded up, it will be 5.4. In this case, this is the 10th digit. In this case, this is the 10th digit. Now what do they want? Which of the following could be the 10th digit? So the digit that could be 10th is 3 or 4. Since 3 is not an option and 4 is an option, 4 is the answer. Okay, so I hope you understand the concept of how to round up, round down. Okay, continuing, now we have terminating decimals, right? So as we discussed, what are terminating decimals? Values that terminate after a certain point. Okay, terminate means values that stop after a certain decimal point, right? 2.5, 3.25, 4.88, 62.289, right? All these are called terminating decimals. Why are they called terminating decimals? Because the values stop or terminate after a certain decimal values. Okay, right? Now one important point, okay, that is, how do we convert these into fractions, right? Converting into fractions, right? So the simplest way to convert terminating decimals into fractions is, you remove the decimal and you divide by that many tenths. For example, if you have 2.5, that becomes 25 over 10. You can simplify it further, 5 over 2, right? 3.25 is 325 over 100, because there are two decimals, so 2 tenths or 100. Okay, 462.289 is 62289 by 1000. 3 decimals, so 1000. Okay, so a very simple way of converting terminating decimals to fractions is simply remove the decimal, divide by that many tenths. Okay, if you understand this, then a very important takeaway comes from this. Okay, the takeaway is, if you think about it, what are we doing? We are counting how many decimals are there, dividing by that many tenths, right? Which basically tells you that denominator of a terminating decimal, right, should be made up of tenths. Okay, denominator of a terminating decimal is 10 power something. Okay, because if I remove one decimal, I get 10 power 1, 2 decimal, 10 power 2, 3 decimals, 10 power 3. Okay, and so on. So if you have 10 decimal values, 10 power 10. Okay, the point is, denominator of a terminating decimal is made up of tenths. Now if we go one step further, okay, here itself, if we go one step further, see here I cancelled the 10 and 25 by 5 and 5. Okay, for this also I can cancel, right? The point is that, okay, the denominator has 10 power x. Now this 10 is split into 2 power x and 5 power x, but when I simplify, I can cancel some 2's out or 5's out, right? So which essentially tells me that denominator of terminating decimal, right? Okay, not of terminating decimal, but of a fraction that gives terminating decimal, is ultimately made up of 2's and 5's. Okay, is ultimately made up of 2's and 5's. Okay, let me not write x because I have already used x, right? Is ultimately made up of 2's and 5. So if I say a fraction can be converted to a terminating decimal. What does that tell us? That the denominator will definitely have 2's and 5's only. It cannot have any other number. Okay, it can only have, right, 2's and 5's. Okay, let's write the only, right? Super important. That denominator of a terminating decimal then will be made up of only 2's and 5's. Okay, it may have only 2's, it may have only 5's, only 2's and 5's, a mixture of 2's and 5's, but it will only have these two prime numbers. No other number will come in the denominator. Okay. Alright, if we understand that, then let's get into the operations. Right, we have, say, fraction and decimal. Right. All of us know addition, right? How to add, right? If there is a fraction, say 3 by 2 plus 7 by 4, or let's do this as 5 by 2 plus 7 by 4. Okay, so you have to do LCM, right? LCM is 4, 5 into 2, 10 plus 7, right? That is 17 over 4, right? What did we do here? In order to make the denominator same, I multiply this by 1, multiply this by 2, so that this becomes 10 by 4. Now that the denominators are same, I simply add 10 plus 7 by 4, 17 by 4, right? Now some people think, or like some of us think that, can't I just multiply? I am not able to do LCM. That's okay, that's fine. Okay, LCM is, you have to simplify your answer to the least fraction. That's okay, but otherwise if you are not able to think of the LCM, don't waste your time. Okay, you can also do 5 by 2 plus 7 by 4, just cross multiply, right? So we have 5 into 4 plus 7 into 2 by 2 into 4, right? That's 20 plus 14, 34 by 8. If I simplify it now, that's again 17 by 4. Okay, the point being, you need not, okay, if you're able to solve using LCM, great, that's the best way. If not, don't waste time finding the LCM, just cross multiply, you can simplify later. All right, and for decimal, right, I hope all of us know this. If you have two decimals, so you just make a 0, right, plus 1.75, that becomes 4.25, right? Now the way addition goes, subtraction works the same way. So if you have 5 by 2, right, minus 7 by 4, same, 10 minus 7 by 4, that's 3 over 4, right? And similarly 2.5 minus 1.75, right? This will become 4, this will become 10, 10 minus 5, 5, 4, again 1, 14, 7, 1 minus 1 is 0, 0.75. Then we have multiplication. Again we have fraction, decimal. Right. So if we have, say, 3 by 2 times 5 over 4, right? So if you're multiplying fractions, just multiply numerator with numerator, denominator with denominator. If there is something that you can cancel, then cancel that. For example, if it was 6 by 7 times 2 by 3, you can cancel this 6 and 2 first, 6 and 3 first, sorry, and then solve. Okay. Coming on to decimals, same decimals. If I do 1.5 times 1.25, so the point is, forget the decimals, just normally multiply 15 times 125. Okay, that gives you 1875. Okay, 15 times 125 is 1875. Now count total decimals. So you have 1 here, 2 here, total 3 decimals. So 1, 2, 3, put a decimal point here. Okay, and last, division, right? Division, of fractions is simply you flip the denominator and multiply, right? So that's 3 over 2 times 4 over 5, and again, as I said, now that it has become multiplication, cancel first, that is 6 over 5. Okay, that is 6 over 5. Similarly, if you have division of decimals, you can either solve normally or convert this also into a fraction and then convert it into a decimal. Okay, how does that work? So that's 1.5 over 1.25. Okay, now see, there is one decimal here, 2 here. Eventually I need to remove two decimals. So what I do, first I make them same. So it's 1.50, 1.25. The number of decimals are same. I can remove the sign. Essentially what I'm doing is I'm just multiplying by 100 and dividing by 100. Okay, so this then becomes 150 by 125, cancel and simplify, which is 6 by 5. Now 6 by 5 you can divide, you will get 1.2. Right? So the point being that for division, remember you have to flip the denominator and multiply. Okay, moving to non-terminating decimals. Now as we saw them like before, they are further classified into two parts. Right, these are further classified into two parts. One is recurring, one are the other non-recurring. Right, recurring and non-recurring decimals. Right, what are recurring decimals? Decimals whose values recur, right, repeat again and again. For example, 2.333, so on, or 5.282828, so on. Right, these values repeat. Non-recurring would be 2.3457912139778. Right, they do not, both of these values do not stop, they go on till infinity, but here the values form a pattern, they start repeating after certain values. Here there is no pattern. Okay, now as we have discussed before, recurring decimals, recurring non-terminating decimals are rational numbers. Okay, they are rational numbers, that means they can be written in p by q, which is your fraction form. Non-recurring are irrational, they can't be written, okay, in p by q form, they are written as is. Okay, so let's learn how to convert into rational numbers. Right, let's learn how to convert these into rational numbers. Okay, so say we have, the example I think I took was 2.3. So first thing we will do is we will say let x is 2.3, right, the value that I want. So essentially I want x in fraction values, right? This can be written as 2.3 bar. Okay, this bar signifies that the value under it, right, repeats. Okay, so 2.33333 is essentially 2.3 bar. Okay, now what do we do? As we will learn later on, right, along with the question, whenever you have infinite repeating pattern, okay, whenever you have a question irrespective of the topic, okay, could be ratios, could be proportions, could be fraction, decimal, any other topic, okay, whenever you have an infinite sequence, which is, or infinite chain which repeats itself, okay, the simplest way to solve is you take the first value out of the chain. Okay, we take the first value outside of the chain because the rest will remain the same. See, from infinite, if you take one, doesn't matter, right, doesn't really change anything much, right? So how do I take one value out? In this case I multiply by 10, right, multiply both sides by 10, right, we get 10x is equal to 23.3333, right, we get 10x as 23.3333, right, which can be written as 10x is 23.3 bar, right. Now X was 2.3 bar. If I subtract the 2, I get 9x as 0.3 bar, 0.3 bar cancels out, right? 23 minus 2, 21. I get x as 21 by 9, which is 7 by 3. Okay, so this is the theoretical way of converting non-terminating recurring decimals to fractions. Okay, now obviously one point will come in your mind that who will do so many steps, right? So for that reason, let's learn a very simple trick of solving these quickly. Okay, so we have, right, method number 2, okay, of converting non-terminating recurring decimals into rational numbers. Now what are rational numbers? P by q, right, is equal to, let's take the same example, right? So p by q is 2.3 bar. Okay, now how do I find p? So the method is very simple. Write the whole number as it is. So you write 23. Okay, we write the whole number as it is. Now hide the bar value. Okay, hide the bar value. So what is left? 2 is left. So minus 2. Okay, see what is the process? What are we doing? We are trying to remove this decimal, right? So how do we do that? Write the whole number as it is, minus, hide the bar value, see what is there, right? 2 is left, so 2, and now divide by, had this been a normal decimal, we would have divided by 10, right? But because it's a recurring decimal, instead of 10, divide by 9. Okay, instead of 10, divide by 9. So if you solve this, this is 21 by 9, which is what, if you think, we got there. Simplify that, 7 by 3. Okay, so remember, what do we do? Okay, what do we do? Whole number without decimal minus number without bar value. Okay, for each recurring decimal, instead of 10, a 9. Okay, let's try some examples, right? Let's try some examples. All right, if you understand this, right, try to find the fractional or rational representation of 5.6 bar, right? Take your time, see 5.6 bar, that is 56 minus 5 divided by 9. Whole number 56 minus number without bar 5, single bar decimal, so 9, right? And then you can obviously solve it. 51 over 9, 17 over 3. Let's take another example, say 25.5 or 25.4 bar, right? This will become 254 minus 25 now, the whole number without bar 25, right, by 9, 229 by 9. Okay, right. If you understand this, let's continue. Let's see. Say the number is 5.28 bar. Okay, now the recurring value is 282828. Okay, so method does not change. 528 minus 5, the whole number minus the bar value, so 5 is left, divide by, now when we had two decimals, normal decimals, we would do 100. So similarly, because we have two bar decimals, we will do 2 times 9, 1 9 for this, 1 9 for this, right? That becomes 523 by 99. Okay, let's take another example. 25.2 267. Right, let's try that. So 25267 minus 25 by 999. Right? Alright. If you understand this, then let's try 5.28 bar is only on 8. Okay, now what is the difference between these two values? See, this means 5.282828, both 2 and 8 are repeating. This means 5.2888, 8 is repeating again and again. Okay, again the method does not change. Okay, again the method does not change. The whole number as it is minus the number without bar, not the number without decimal, the number without bar. So if I hide this 8, I have 52 left. So minus 52, divide by, for bar decimal 9 should come. So this is taken care of. But what about this 2? This is a normal decimal. So for a normal decimal 10 will come. Right? See, for this bar decimal 9 comes. For this normal decimal 0 comes. Right? And likewise in the numerator, the whole number as it is minus, now number without bar is this, right? Number without bar is this, so that's 52. Okay, now you just solve and simplify. 476 by 90. Okay. Doesn't go by. Okay. Right, 238 by 45. Okay, I hope you understand this. Right, if you do, chalo, let's try a couple more examples. 25.267, the bar is only on 7. Okay, yes, 25267 minus 2526 whole divided by 9 normal decimals to 0 0. Okay, let's look at one more example. 25.267, the bar is on 6 and 7. So this will become 25267 minus 252 by 990, 990, 9 for this, 9 for this, 0 for this. Right? So this is how you can convert all your recurring non-terminating decimals into simple fractions or rational numbers. Okay. Alright, moving to the questions. So we have, what is the 25th digit to the right of the decimal representation 8 by 33? Okay, so we have to divide 8 by 33, we will get some answer. We have to find the 25th digit. Okay, we have to find the 25th digit. Alright, now one way to solve, right, would be just simply divide, right? 8, 33, 0, put a decimal so that you can carry a 0. 2s are 66, 14, 140, 33, 4s are, right, 33, 132, again 8, 0, right, 2, 66, 14, 4 and so on. Right, so you realize this is 0.24 bar. Okay, so we understand that this is 0.24 bar. That means the answer is 0.24242424 and so on. You know, all the odd digits are 2, all the even digits are 4. So since we want the 25th digit, that will be 2. Right, that will be 2. Okay, but again, see, if you are comfortable with the table of 33, no problem, just do this. It's a very simple way, right, of doing it. or what can be a simpler way or easier way, right? So see, these are recurring decimals, right? We know because there is no 2 or 5 in the denominator, so we know this is a recurring decimal, right? A question comes, all the recurring decimals that I have understood, which we have solved as of now, they used to contain 9 in the denominator, right? The denominator was either 999, 990, 900, but it used to contain 9, and then you simplified it, right? So what I am thinking is that, can I convert somehow this denominator into 9? Correct? I can multiply by 3, right? We can multiply by 3. So what happens? I get 24 by 99, right? I get 24 by 99. Now, whatever we have learned just now, if this is 24 by 99, what do I know? This is 0.24 bar, because 0, right? 0.24 bar, because 24, that because of 24, the recurring decimals, the denominator will be 99. How can I get 24 in the numerator? Point, if I just add a 0. If you try to convert this, this is what? 0 to 4 minus 0 by 99. That's 24 by 99, right? So instead of solving the table of 33, what did we do? We converted in this fraction into a fraction that we understand more easily, right? And that is, we converted this to 99, right? 24 by 99, right? Which is 0.24 bar. Again, I have the same step. So I know this is 0.242424. I know the 25th digit is going to be 2. Okay, so don't just start solving. Okay, try and think if you can apply the concept that you have learned. Okay, all right. So if you have understood the previous one, right, this is very similar, right? We have all the fractions are written as repeating decimals, right? We want the longest sequence of different digits. That means we want the recurring decimals to be longest, right? Again, right, if you want, you can solve all of these. You can divide what, 3 by 11, 1 over 3, then we have 29 over 99, 4 over 9, and then 19 over 37, right? So if you want, you can divide all of them and check, right? Or what we have learned previously, if I want to know the recurring decimals, let me make the denominators 9, right? Let's try to make denominators 9, right? So in order to make this 9, multiply by 9, 27 by 99, I know this is 0.27 bar, right? So it's a 2. The sequence here is 2. Same way, multiply, divide by 3, you will get 3 over 9, which is 0.3. Sequence is 1. This we directly know is 0.29. Again 2. This is 0.4. Again we know sequence is 1. This is already, right? Now if you look at the fifth number, this is already a 2-digit number, right? If I try to convert it into a 9, it can't become 99, right? This cannot become 99, right? So that means whatever the decimals are, that will be more than 2, right? This might be 999 or 9999, right? So then whatever the recurring decimals are, they will be more than 2. So the longest sequence will be of this, right? Now if you want, we can solve this also. So first thing I do is I multiply by 3, okay, because I know 37 into 3 is 111, that's 57. Now that I have 111, again I multiply by 9, okay, That's 513 over 999. Okay, that's 513 over 999, which is 0.513 bar. Okay, again, the point I am trying to make is, instead of doing actual division, just apply the logic. You'll be able to solve the question orally. Okay. An interesting question. The club has n members. 2/5 are girls. They play one of the three chess variants. 1/3 of the boys play blitz. 5/6 of the remaining boys. Okay, this is very important. Remember one thing. Whenever you go through percentages or fractions, okay, whenever you are studying percentages or fractions, press or give emphasis on this word of. Okay, it is percentage of what? It's fraction of what? Fraction does not mean that I have to take directly from the total. Okay, I need to understand the fraction is of what. So this of and what comes after the of is super important. Okay, now rest of the boys play this. How many in terms of this play classical? Okay, alright, let's simply make a tree. Total people at the club are n. Okay, 2/5 are girls. So girls are 2/5. That means remaining 1 minus 2/5. That's 3/5 are boys. Okay, 3/5 are boys. Now 1/3 of the boys play blitz. So 1/3 of these play blitz. Okay, 5/6 of remaining. So first of all, how many are remaining? Again 1 minus 1/3. That's 2/3. These are the remaining boys. Okay, now of these 5/6 play rapid. Okay, and the rest, again what is rest? If 5/6, 1 minus 5/6, that's 1/6, right? These 1/6 they play classical, right? These remaining 1/6 they play classical. The question is, in terms of n, how many play classical? So classical will be this 1/6, right? Just step up the ladder. 2/3, 3/5 of n. So classical will be 1/6 times 2/3 times 3/5 of n, right? This is 1/6 of 2/3 of 3/5 of n, right? Now you just solve it. 3 and 3 cancels out. N by 15. Okay, so again, don't just rush that. Okay, I have read the statement and start solving. You can simply make a tree. Okay, you can simply make a tree and solve the question quickly. Moving on, a very similar question. Okay, we have 3/7. She's already saved that much. 2/5 of the remaining, right? What fraction of total is left? Okay, the question is again, what fraction of total is left? Okay, so same, we'll make the t. Let total cost be 1. Okay, let total cost be 1. Now what has she done? 3/7 she had already saved. So 3/7 already saved. So how much more does she need? 1 minus, that's 4 by 7, right? So this is my remaining amount, right? Now of this, she intends to save 2/5. That's your expectation, right? She expects to save 2/5. So how much is left? 1 minus 2/5, that is 3/5 is left, right? So again the question is what fraction of total? So I have to go till total. She still needs to save. So how much is required? How much is required? So this is required. So here to here I'll go. So that is 3/5 of 4/7 of 1. That's 12 by 35. Okay. Another way to solve this probably, right? Another way to solve this probably could be you can just take values. See, the question has no value given. So look at the denominators now, 5 and 7, right? Look at the denominators here, right? The denominators are 5 and 7. LCM, a number that goes by both, 35. So if you want, you can take the total cost as 35 and then also go. So for example, if I take the total cost as, say instead of 35, I'm taking 350. Okay. Just to tell you that number doesn't matter. What number you want, you can assume anything as long as it goes by 7 and 5. Why 7 and 5? So that your calculations become easier. That's all. So she has already saved 3/7, right? 3/7 of 350 is 150. So we know she needs 200 more. Okay. And then she expects to save 2/5 of this. 2/5 of this 200, that's 80. So she will still need 120 more. She will still need 120 more. Now question is what fraction of the total cost does she still need to save? So she needs to save 120 out of 350. So that is 12 over 35. Alright, moving on to the next one. So we have sum of reciprocals of consecutive even integers, and they are asking larger of the two integers. Okay, so since these are consecutive even integers, so the first integer is x, second integer is x plus 2. Sum of the reciprocals are 1 by x, 1 by x plus 2. Sum means addition, is 9 over 40. Right, let's just solve this. Again we do LCM. X into x plus 2, x plus 2 plus x is 9 over 40. If you do, that is 2x plus 2 over x square plus 2x is 9 over 40. That's 80x plus 80 is 9x square plus 18x. Right? Get everything on the same side. 9x square minus 62x minus 80 is 0. Right? 9x square minus 62x minus 80 is 0. Right? Now if you know quadratic equation, product of first and last is 720. So I'll break it as 9x square minus 72x plus 10x minus 80 is 0, because 72 times 10 becomes 720. Take 9x common, x minus 8 plus 10 common, x minus 8, x minus 8, 9x plus 10 is 0. Either x is 8 or 9x plus 10 is 0, x is minus 10 by 9. Since these are consecutive even integers, x has to be 8. Okay. Again, do not rush and just mark x as 8. Okay. Hold your horses. What do they want? The larger of the two integers. X is the smaller one. Larger one will be 10. Okay. Remember that. Always read the question line. Alright, if you've read this, this looks very similar to a topic we did, overlapping sets or Venn diagrams, the table method, right? See, how do I know that? See, if you read, it says, right, there are hardcover books, you are selling some of the books, so there are two variables, right? One is sold, unsold, hardcover. So if you want, we can go with our table. Hardcover books, not hardcover books, total. Sold, not sold, total. Right? Right. What do we know? Again, total is 1, right? Because total fraction is always 1. 1/4 are hardcover. So 1/4 are hardcover. That means 3/4 are not hardcover. Store sold 2/3 of sorry. Store has sold 2/3 of the books. So how many left unsold? 1/3. Now including 4/5 of hardcover books, right? Again, as I said, whenever you are looking at fraction, focus on fraction of what? So it's a fraction of it's not 4/5 of the total. It's 4/5 of hardcover books. So 4/5 of hardcover books. That's 1/5. Okay, so hardcover and sold is 1/5. Now that I have this fraction, let's just do subtract. 1/4 minus 1/5 is 1/20. 2/3 minus 1/5 is 2/3 minus 1/5 is 7/15. 1/3 minus 1/20 is 20 minus 3, 17/60. Right? If you want to verify, let's add these. 28 plus 17, 45/60. That's 3/4. My addition, right, comes up. So that means everything is correct. Now read the question again. The question is not solved yet. What fraction of unsold books were hardcover? Again, what means X? Fraction of unsold books. What are the unsold books? 1/3. Right? So what fraction of unsold books were hardcover? Hardcover are 1/20. Right? So X is 3/20. Okay, X is 3/20. Now, same thing if you want, right? Same thing if you want, you can also assume values, right? Same thing if you want. Again, as I said in the previous one, if you don't want fractions, if you are not comfortable with fractions, no problem, right? Just assume values. Again, how do we assume value? So see, look at the fractions: 1/4, 2/3, 4/5. Denominator is 3, 4, 5. Quickly think of a number that goes by 3, 4, 5. Okay, don't waste your time. Quickly think. 60 works, right? If you're able to think of 60, works. 120, 300, everything works. Just pick one number, right? So if I take 60, so total becomes 60. Now just solve the question with respect to 60. 1/4 were hardcover. That means 15 are hardcover, which means 45 are non-hardcover. 2/3 were sold. 2/3 of 60 means 40 were sold, 20 were not sold. 4/5 of the hardcover were sold. 4/5 of 15, that's 12. That means this becomes 28, this becomes 3, this becomes 17. Right? Now question comes, what fraction of unsold? So unsold is 20. Were hardcover? Hardcover are 3. So fraction again becomes 3/20. Moving on to the next one. Right. So we have 2/3 of the eggs laid by flamingo hatched. 3/4 of the hatchlings survived the first month. Of those that survived, remember again, of those that survived, 3/5 did not first year. 150 survived the first year. How many hatchlings survived the first month? Okay. So again, let's simply make our tree. Say total there are X. Okay, total eggs that were laid by flamingos, right? Total eggs laid, let that be X. Okay, now what is happening? 2/3 of these hatched, which means 1/3 did not hatch. Okay, now of the hatched, 3/4 of the hatchlings survived the first month. So 3/4 of this survived the first month, which means 1/4 of these did not survive. Okay, now of those that survived, so of these 3/5 did not make it through the first year. 3/5 did not make through first year, which means 2/5 made, right, first year, right? If 150 flamingos survived the first year, so this, my friends, this is 150. So what is this? This is the path I need to follow, right? So 150 is 2/5 into 3/4 into 2/3 into X, right? This is the path I need to follow, right? 3 and 3 cancels, 2 and 2 cancels the 4, X is 750, right? X is 750. Again, don't mark, read the question. What is it that they want? How many hatchlings survive the first month? First month means I want this. Okay, how do I get this? I go from here to there. So that is 3/4 of 2/3 of X, total hatchlings, which are 750. Okay, 3 and 3 cancels, 2 and 4 cancels, 375, right? 375. Moving on, guys. So we have country A, 12 Zint coins is 1 lurk. Country B, 8 franc coins is 1 tobble. Okay, lurk is 50% more than tobble. Ratio of Zint to franc. We need to convert, or we need to find a relationship between Zint and franc. Okay, what do we know? 12Z is equal to 1L and 8F is equal to 1T. Okay, and 1L is 50% more. 50% more means 150% of 1T. Okay, so 1L is 3/2T, but we want the ratio between Z and F. So let's replace L by Z. So that's 12Z. Let's replace T by F. 3/2 times 8F. 12Z is 12F. Z is F. Z by F is 1/1. Ratio is 1:1. Moving on to the next one, we have 1 meter in length marked in fourths. Fourths means 1/4. Okay, so quarter, 1/4. And fifths. Fifths again means 1/5, 1/5, 2/5, like that. So we have a 1 meter length rod. It's cut into separate pieces. We need all different lengths of the pieces. Okay, as a in fraction of meter. Okay, fine. Let's draw the rod first. This is the rod, right? Let's first break it into fourths. Right. So this is 1/4. This is 2/4, which is essentially half. This is 3/4, and this is 4/4 or 1. And this is your 0. So this is the scale. Starts at 0, goes on till 1 meter scale. Now I need to break it into fourths as well. Okay, I need to break it into fifths as well. Sorry. So 1/5. Now this is where understanding comes into play. See, you should know 1/5 is less than 1/4, right? So this is where my 1/5 will come. 2/5, 3/5, and 4/5. Okay, so I've broken the metal rod into fifths also. So if you count, you have 8 pieces. 1, 2, 3, 4, 5, 6, 7, 8. We have 8 pieces. Now we want length of each piece. If you look at length of this one, it's simply 1/5 minus 0, which is 1/5. Okay, length of this piece, 1/4 minus 1/5, that's 1/20. Length of this piece, which is 2/5 minus 1/4, 3/20. Length of this piece, that's 2/4 minus 2/5, that is 2/20, right, which is essentially 1/10, right? Again, if we do this, that's 3/5 minus 2/4, right, that's 2/20, 1/10. This is 3/4 minus 3/5, that's 3/20. 4/5 minus 3/4, 1/20, and 1 minus 4/5, which is 1/5. Okay, so these are the 8 lengths. One thing you will observe, right? One thing you will observe. Let's see, the first and last are same. Second from last are same. Third from last, and fourth and fifth, they are same. So it's basically broken into symmetric parts, which kind of makes sense also, right? So now, what are the various lengths? 1/5, 1/20, 3/20, 1/10. Right? These are the lengths. Okay. Now, obviously, this is one way to solve it, when you know actually write down the fractions and solve. But as I've been telling you in the previous questions, if no value is given, right, a faster way to solve could be to assume values, right? Now, instead of taking the rod as 1 meter, let's assume a value for the rod. See, it's 1/4 and 1/5. So denominators are 4 and 5. So what do we assume the value as? 20, right? LCM. So say the length of the entire rod is actually 20. This is 0, this is 20. Now when I break it into fourths, right, which is 1/4, you know those values. The values are 5, 10, and 15. Right? Now if you want to break this further into fifths, fifths means 1/5. So you know those values are 4, 8, 12, 16. Right? And now all you have to do is calculate various lengths. You can do so orally. This is 4, this is 1, this is 3, this is 2, 2, 3, 1, 4. So the various lengths are 4, 1, 3, and 2. Right? But we want fraction of the total. So divide by total is 20. Right? 2/20 is 1/10. 4/20 is 1/5. The other two values are there. So, okay, the point I am trying to make is, if you're comfortable with fractions, do that, no problem. If you are not, assume value, right? It's much faster and easier to do. Moving to the next one, we have x, y, z are all positive. Okay, fine. X by y, x by z is given. We need to know the smallest value, right? All right. So we have x by y as 7 over 3. We have x over z as 5 over 4, right? So if I just write this in ratio form, right, I get x is to y is 7 is to 3. X is to z as 5 is to 4. Okay, this is x, this is y, this is z. Now if I want to combine, the common variable is x, right? If I want to combine, the common variable is x, so I need to make the value of x same. If you're finding this little difficult to understand, we have covered this in ratio proportion. Okay, so if you want, you can watch that video. What we are basically doing is, see, we know the comparison between x and y, x and z. Now I want to compare x, y, z together. How do I do that? I make the common variable equal, right? How do I make it equal? LCM, right? So if I multiply the first ratio by 5, I get x is to y as 35 is to 50. Multiply the second ratio by 7, I get x is to z as 35 is to 28, right? Now when I combine, because the value of x is same, x is to y is to z, 35 is to 15 is to 28, right? X is to y is to z is 35 is to 15 is to 28. Again, so from here I know x is 35k, y is 15k, and z is 28k. Don't just directly assume that x, y, z are 35, 15 and 28. Okay, they can be some other numbers also, right? So x is 35k, 15k, 28k. Now what do I want? I want 3x plus y. 3x plus y will be 3 into 35k plus 15k. That's 120k. But again, I don't know k. Now the question says smallest value. So the smallest value of k is 1, because they are all integers and positive. The smallest positive integer is 1. So since smallest value of k is 1, the answer becomes 120. Alright. Moving on to the next one. So we know k is sum of reciprocals of 10 consecutive integers. K is between. So we don't want the exact value of k, we want a range for k, right? Let's write down k first. K is 10 consecutive integers, 31 to 40 reciprocals. Okay, so k is 10 consecutive integers reciprocals. So 1 by 31, 1 by 32 and sum 1 by 33 and so on, 1 by 39 and 1 by 40, right? So k is sum of all of these numbers. Now again, if I try to add, not possible, right? It's going to take time. LCM and all will take so much time, right? So I have to think of a different way. Plus I want range. I don't want the exact value of k, correct? So we go to the concept of basic fractions, that is, the greater the denominator, the smaller the number, or the smaller the denominator, the greater the number. Okay, what does that mean? That instead of finding k, let me find the range of each of these values. Okay, so if I look at 1 by 31, it's definitely more than 1 by 40. Okay, smaller denominator, greater number, and at the same time it is less than 1 by 30, right? Similarly for all the numbers, 1 by 32, right, 1 by 33, right, and so on, 1 by 39 and 1 by 40, right? Now you know if you have inequalities of same sign, you can add all of those. So let me add, this will become 1 by 40 plus 1 by 40 10 times less than 1 by 31 plus 1 by 32 1 by 39 1 by 40 less than 1 by 30, that also 10 times, right? Now if you see, these are 10 numbers, so 1 by 40 10 times is essentially 10 by 40. This, right, sum of all of this is what is my k, right? And 1 by 30 10 times is 10 by 30. So if I solve this, k is between, right, 10 by 40 and 10 by 30, which is 1 by 4 and 1 by 3. Okay, the point I am trying to make is that don't just read the question, write it down and start solving. Okay, apply your brain. Okay, take your time, think what is it that they want. Do you really want to solve so much calculation? Remember, the objective of our exam is not to make us calculate a lot. Okay, it's about can you apply logic or not. Okay, so if something like this comes, think what can be a way, like a smarter way to solve. Okay. This looks like an inequality question. So we have x by y greater than 1. We already know x and y are positive integers. Which of the following must be less than 1? Oh, now don't just jump the gun and start plugging in values. Okay, we have discussed this in inequalities. Try to solve it theoretically so that you can answer confidently. Okay, don't just jump the gun and just start plugging values. Okay, you may or may not get the answer, or you might take time and you may not be confident enough, right? In the end, let's just solve it. It's very simple. We know x over y is greater than 1. At the same time, we know x and y are both positive integers. Okay, why is this important? Because if I know that the variable is positive, I can cross multiply it without changing the sign. Okay, let's recall that. See, we have done this in inequalities. All right, those of you haven't, you can watch that video. The point is that if you have variables in inequalities, you cannot cross multiply them just like that. The only way you can cross multiply variables is if you know the sign of variable. If the variable is positive, cross multiply. Okay, cross multiply and keep the sign same. Okay, but if variable is negative, you can cross multiply then also, but then you have to change the sign. Okay, you have to change the sign. Here we already know that x and y are positive, so we can cross multiply and keep the same sign, right? If I just take this one step further, I get to know y by x is less than 1. Okay, just take this one step further, I know y by x is less than 1. But none of these options are less than y by x, sorry, right? None of these options are y by x. No problem. Let's solve option by option. X by y. From the question itself, I know it is greater than 1. So this can't be it. X by y square, right? If I solve, so I know x by y is greater than 1. For x by y square, I need to multiply by 1 by y. So I get x by y square is greater than 1 by y. Okay. Now greater than 1 by y, 1 by y is going to be a decimal value, say maybe 0.2, 0.3, 0.4 something. So I know x by y square is greater than a decimal value, but that could be 2, 3, 4, 5 also, right? So it's greater than a decimal. Is it less than 1? I don't know, right? I don't know. Okay. Moving on to the next one, x square by y. Again, I know x by y is greater than 1. If I multiply both sides by x, x square by y will be greater than x. Again, why am I able to multiply? Because I know x and y are positive, so I don't need to change the sign. Okay, so I know x square by y is greater than x, right? Is it less than 1? I know x and y are positive integers, I know x is greater than equal to 1. So x square by y has to be greater than equal to 1. Okay. Let's look at fifth option because it looks similar to y by x. Okay. So we know y by x is less than 1. Let me multiply, right, both sides by 2. So I get 2 greater than 2y by x, or basically 2y by x is less than 2. So I know 2y by x is less than 2, but is it less than 1? Again, I don't know. Could be 1.5, 1.9, 1.8, right? So tempting option, but not the answer, right? Which obviously leaves us with y by x square, but let's just solve it, right, for our own knowledge. So again, to get y by x square, right, I need to multiply both sides by 1 by x. So I get y by x square is less than 1 by x, right? Since y by x square is less than 1 by x, and I know 1 by x is less than 1, right, because x is greater than equal to 1, right? I know 1 by x is less than equal to 1, so y by x square has to be less than 1. Okay, right? So again, what I'm trying to say is, don't just jump and try and plug in values. Okay, understand it, you'll be able to solve everything theoretically. Looks like an interesting question. So we have x is a positive number, okay, which is fine. We have the value of x is this infinite chain, okay, and we need to find x. Now, if you guys remember a few questions ago, I told you that whenever there is an infinite link, no problem. What do? We remove one value from the link and the rest remains the same, because from infinite numbers, if you just remove one, it won't matter much, correct? So let's apply that logic here, right? So before we do, let's just write down the question. See, x is 2 over 1 plus 2 over 1 plus 2 over, and so on. Okay, this is what the value of x is, right? Now, as I said, that if you remove one link, how do I remove? So let's figure out from where is this value repeating. So see, it starts from 2. So this is the place where the value repeats. Okay, this is the place from which the value repeats. So if I remove this, okay, let's say I remove this, right? Now if you just look at it, okay, whatever is left, if you just look at this, what can you say, right? This is equal to x. There is no difference between this and that, correct? So this is essentially equal to x, right? Does that make sense? Let's bring that back together then. Okay, so this essentially means this is x. Okay, now if you understand this, question is solved. So we know x is 2 over, we know x is 2 over 1 plus x. This entire thing has been, right, this entire thing here has been replaced by x. Okay, now this solve. X square plus x is 2, that's quadratic. Square plus 2x minus x minus 2 is 0. X common, x plus 2 minus 1 common, x plus 2 is 0. X plus 2, x minus 1 is 0. X is either minus 2 or plus 1. Okay, and since we know it's a positive number, right, that is why reading the question is important. X has to be 1. Okay, the point is, whenever there is an infinite link, irrespective of the topic, whether it is this fraction, decimals, ratio, proportion, percentage, any other topic, right, algebra, remember, for infinite, just remove the first link. Okay, the rest is the same. Okay, all right guys, I hope you understand fractions and decimals. Okay, I hope I was able to make it very easy for you. Right? See you in the next one. Hi guys, so I hope you like the way we covered this topic. Remember, this was a concept builder video wherein we covered a simple concept and tried to solve all the questions using that concept. There is an advanced video with more tricks, right, that will come as part of this series. If you have any doubts, you can post them in the comment section and we can make a solution video for that. Also, you can practice free material of the same topic from our website, okay, and take those tests.